12-20, and I'll spend some time. I'm going to show you this 12-19, but it's more going to be like your 22. Maybe going to help you out a little bit there. So I'll spend a little time though talking about number 20, because that's completely different, although some information on here might be helpful. So it's one of those times, it's hell getting old, but when I last did this, I obviously set these two columns up, and for the life of me I can't remember why, because they don't really have anything to do with solving this. So I guess today's lesson about that is that it's hell getting old. Anyhow, again, here, this is with replication, meaning that there could be some interaction between these, or one dependent upon the other. And so we'll let Excel do the work for us. And how do we do that? Data analysis, two-factor with replication. So I'm going to click on that. My input data, and I actually had this all kind of lined out, but there it is. Rows per sample. Okay, I got heavy is one sample and light is another sample. So I've got 1, 2, 3 rows, 3 rows per sample. Okay, and they have to be, I think they have to be equal if I'm not mistaken. And I'm going to put this one, because I've already got this one over here, but I'm going to put it on a new worksheet, and we'll just go take a look and make sure that it turns out the same, and it did. Okay, and we'd interpret this a lot the same. Our null hypothesis would be that that the means of the I believe the samples are the rows, that the means of those are similar, and if our f calculated exceeds this, we would reject the null. So in this case, we would not reject the null, and so we would say that they're probably equal. And in this one, we would say, because the f value, the columns then, I guess if this is columns, this one has to be rows, but they call it sample. We would say that our columns, we cannot reject the null as well, and so our columns are equal. Now, when it comes to the interaction, okay, we would say that using the f value, that if I think our hypothesis is that if our calculated f value on the interaction is greater than the critical value, we accept the fact that there is no interaction. Okay, so I believe our null hypothesis is that there is no interaction, and so if our null hypothesis is that there is interaction. Yeah, our null hypothesis, I got to rephrase that, I'm sorry, is that there's no interaction. So the fact that this is less than that means we accept the null, and so there is, in fact, no interaction between these two sets of data. So one isn't necessarily dependent on the other in that case. Okay, I'm going to pause for a second. We can, and the book kind of, I think, does this. It says you can also look at the p-value, and if our p-value is greater than 0.05, our significance level, right, then there is no interaction. Okay, so both of those. Again, I'm kind of using a hypothesis that I don't know if the book even talks about that, but basically, if our f value is less than our critical f, then we can assume that there is no interaction, and the p-value here would confirm that. So your number 20, okay, so to talk just briefly about that, it gives you a basic ANOVA structure, right, like we have here, but it's hardly filled out. And it does give you some information in 20. It says, consider the following partially completed 2A ANOVA. Suppose there are 4 levels of factor A and 3 levels of factor B. Okay, the number of replications per cell is 5. Wow. Okay. Complete the table and test to determine if there's a significant difference in factor A. The thing to do is look back then on page 407, and toward the bottom, it's in the yellow box. It really tells you how to do that. And you've got, the source of the variation, right? You've got the sum of the squares that they give to you, okay? And so what you have to do is then determine the degrees of freedom by using the information that they give you there. Okay, again, I'm going to pause for just a second. So when you're looking at that, then you go all the way over to the left, because they use the same verbiage. And your problem, they got factor A and a factor B. Okay, and then the interaction. So factor A, the degrees of freedom is just k minus 1. And as you read, our problem, it says, suppose there are 4 levels of factor A. Okay, so that would be 4 minus 1 then, right? And there's 3 levels for factor B. Okay, and so then that's the next one down, and so that would be 3 minus 1. Okay, then your interaction is just those two actually multiplied by each other. Now, when you get to the total, the total of n, okay, that's probably the toughest thing to figure out. Okay, because if you go to the bottom, your total, and you want to figure that out, then really before you figure out the error. But in any event, it's the 3 times the 4 times the 5. 3 times 4 times 5. So n is 60, right? And then your total degrees of freedom obviously be 60 minus 1. From there, just do the math based on the mean squares and the f, and the information should kind of show up or be doable as you fill that in. So, just set it up kind of like you have here, and fill in that information as best that you can. Okay, this one's kind of a tough one. It's I'm not going to say that it's bonus necessarily, but we'll take a look at how everybody does and try to be kind in grading on it. How's that? Good luck.